Bright Tuty. Every student matters.
Hello everyone, welcome back. So as we said that in the next lecture we are going to discuss about the divisibility test of numbers. Let's start with it. So in the test for divisibility of numbers, we are going to start with the number 10 because that is the thing easily noticeable by you. So just stay here. So we will start with the divisibility rule for 10. Okay, like how do we get to know what is the divisibility test to check whether a number will be divisible by 10 or not? So we'll write divisibility by 10. Now, let's write the multiples of 10. The multiples of 10 are 10, 20, 30, 40, 50, and so on. Yes, like you will get 100, you will get thousands as well. Okay, what is the common thing that we can observe? We can observe one common thing which is quite easy to notice. In every number, the units digit, if we focus on, see the unit digit, that is 0 in all of the multiples of 10. Okay, 10 is a multiple of 10, that is the first multiple of 10. So all of these numbers have the unit digit, or I say the ones place digit as 0. So what is the conclusion? That if a number, what we will write, what's the conclusion that we can form, or what is the test that we can do? If a number has 0 in its units place, or we can say ones place, okay, it is divisible by 10. What is it? Divisible by 10. So what do we say? What is the divisibility test for 10? In case you see at the end of the number there is a 0, that means at the units place or at the ones place you see a 0 in the number, then we say the number is divisible by 10. Clear? Let's now do the next one, which is also an easy one, that is divisibility by 5. Okay, so when we do the divisibility with 5, let us write the multiples of 5 as well to notice this. The multiples of 5 are 5, 10, 15, 20, 25, 30, 35, 40, and so on, like 125 also, 150 also, you will get like this. So these are all the multiples of 5. Do you see any pattern in the digits? Yes. What do we observe? We see that the units digit, okay, is either 5, or the ones digit I say is 5 or 0. Every time just see either it is 0 or it is 5 in all of these. Okay. So what we can say, a number which has, so what will be the conclusion? A number which has 0 or 5 at its ones or the units place. Okay, if we say this is there, then it is divisible by 5. Quite easy to understand. Okay, so what is the divisibility rule of 5, students? We just have to see if the units digit is 0 or 5, then it is going to be divisible by 5. Can we say all the numbers which are divisible by 10 are also divisible by 5? Yes, we can say it, all the numbers, because all the numbers that are divisible by 10, that means they have a 0 at the end. That means 0 at the units place or the ones place. So that fulfills the requirement for divisibility of 5. Either it should have 0 or 5 at the end of the number and it would be divisible. So what about this number? Think about this. If I have 1750125, if I have this, do you think this is going to be divisible by 5? Obviously, when you divide, you're going to get the remainder as 0. It will be exactly divisible by 5 as the units place is 5. Clear? Okay, now we are going to discuss about the next rule, and let's do it for 2. Okay, So the next that we are going to do is that is divisibility by 2. Okay, what about the multiples of 2 if we think? The multiples of two students, suppose I write, it is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and so on. Let's see the pattern. What do we observe at the units place? Either it is 2, 4, 6, 8. So these are just one digit numbers. Let's go to the 2 digits. So I have 0 as the units place, 2 as the units place, 4 as the units place, 6 as the unit place, 8 as the unit place. Again you see 0, 2, 4, then 26, 28 and 30 like this will come up. So again this set is repeated. 2, 4, 6, 8 was there and 0. Now again 2, 4, 6, 8, 0. 2, 4, 6, 8, 0. So this set of digit is repeating. That means if at the end or the last digit, or I say the ones digit, units place digit is 2, 0, 2, 4, 6, 8. If it the number is ending with any of this digit, then the number is divisible by 2. Okay, so if the number ends with these digits 2, 4, 6, 8 and a 0, then we say the number is divisible by 2. This is the divisibility test for 2 or the divisibility rule for 2. Okay, let's discuss the divisibility rule of 3. So, in divisibility rule of 3, let's write the multiples of 3 as we have been doing the same. So, 3, 6, 9, 12, 15, 18. Okay, we will write like some. Okay, after 18, 21, then 24, then 27, 30 and so on we will have, because multiples are infinite. So what do you observe? Do you observe some pattern? Do you observe some pattern in the units place or ones place? No. Actually, it can end up with 0, it can end up with 0, it can end up with 7, 4, 1. You know, if I think that if digit is ending with 7, it will be divisible by 3. So that is not the case in all. Like 17 is there that ends with 7, but it is not divisible by 3. So what I have to think, I need to think some other way out so that I can find out if the number is divisible by 3 or not. So when it is 1, you know, that is a multiple. Okay, so 3 can be written as 0, like 3 I can write it, 6, 9, then 12, then 15, then 18 we have. Okay, let's try to add these digits. Okay, it will be 0 plus 3, that is 3 only. Okay, and 0 plus 6, if I say it is 6 only, then 0 plus 9 is 9. 12, that means I have to add both the digits. I get 3. 1 plus 5 I do, I get 6. 1 plus 8 I do, I get again 9. Then next is 21. So 1 plus, 2 plus 1, that is 3. You see, again it is repeated 3, 6, 9, 3, 6, 9, like this we are getting. So what do you have to do? Whatever number you get, you add all the digits of that number. Okay, if you do that, suppose I get I get suppose 243. Okay, I will add all the digits 2 plus 4 plus 3, and I'll see 4 plus 2 is 6, 6 plus 3 is 9. It is giving the sum as 9. So this do you observe one thing, that when I am adding the digits, the summation, the addition of all of these digits of that number, if that is coming as a multiple of 3, in the case you can see it is coming as 3, it is coming as 6, it is coming as 9, all are multiple of 3. So if the addition of the digits, all the digits of that number gives you, okay, the addition answer is a multiple of 3, it gives you a multiple of 3, then we say it is divisible by 3. Clear? So what we have to do for divisibility test of 3, add the digits of that number. If the answer or the addition comes out to be a multiple of 3, you say that complete number, whatever the bigger number is, it is going to be divisible by 3. Suppose I take an example of 1296. Okay, let's take this. Add them. 1 plus 2 plus 9 plus 6. Add them. So 2 plus 1 is 3. 3 plus 9 is 12 and 12 plus 6 is 18. Is it a multiple of 3? Yes. So this number will be exactly divisible by 3. This is how you do the divisibility rule for 3. Okay. Now let us discuss the divisibility test for 6. So divisibility test by 6. Okay. Now what we do, suppose 6 is there. 6 can be written as 2 into 3. 6 is divided by 2 as well as by 3. Okay. Let's consider some number as 12. Okay. 12 can be written as 6 into 2, also can be written as 6, can be written as 3 into 2 into 2, or we can write it as 3 into 4. So do you observe one thing, that 12 is divisible by 6, also divisible by 2, also divisible by 3. Okay, if I see 18, okay, it is divisible by 6, 6 into 3 we write, and it is divisible by, like we can write 2, 6 can be converted to 2 into 3. So this is there, then 9 into 2 is there. So you see it is divisible by again 3 and 2 as well as 6. So all the multiples of 6, they are definitely divided by 6. But the common thing that I am observing here is that 2 and 3 is coming in all the as all the factors, where 6 is a factor of some number. So multiples of 6 are 6, 12, 18, and all of them are also divisible by 2 and 3 both. So what is the conclusion? I want you to notice here is the number will always be divisible by 2 and 3 both, not just 2 and not just 3. It should be divisible by both 2 and 3. Then we can say it is divisible by 6 as well. Okay, shall we take some example that is just divisible by 2 and not by 3? Suppose I have 14. It is divisible by 2 but not by 3. So it is not divisible by 6 as well. We can see it is just divisible by 2, not by 3. But if I take a number that is divisible, like suppose I take 24. It is divisible by 2. Yes. 24 is divisible by 3. Yes. Both of them are exact divisors of it. Then we say 6 also divides it. Okay. So what is the divisibility rule for 6? It should be divisible by 2. 2's divisibility rule we have already discussed, that if the number ends with the digit 0, 2, 4, 6, 8, then it is divisible by 2. What about 3? You have to add the digits and see the addition is a multiple of 3. It is divisible by 3. So for checking whether a number is divisible by 6 or not, what you need to do? You just have to check that it is divisible by 2 as well as by 3 simultaneously at the same time. That should be divisible by both 2 and 3. Then we can say the number is divisible by 6 as well. Similarly, students will discuss the divisibility rule for 9. Let's try. So we will mention divisibility rule for 9. Okay, or we can say of 9. So when we have to check whether a number, okay, is divisible by 9 or not, what do we do? So let's take the multiples of 9. 9 ones are 9, then 18. Like this we will be getting 9 ones are 9, 9 twos are 18, 9 threes are 27, 9 fours are 36, 9 fives are 45, 9 sixes are 54, and like this. Okay, there is no pattern that we can observe in the units place, because it is 9, it is 8, it is 7, then 6, then 5, then 4. Even you will get 63. Yes, you will get 72, and then 90 also you will get, 81 you will get, 90 you will get. So do you see the units digit is getting decreased, like it is 9, then 8, then 7, then 6, then 5, then 4. So we cannot have some pattern in this one. But yes, let's try to add the digits. See, 9 is there, that is 0 plus 9. The sum is 9. 18, I can add the digits. Yes, I'm getting 9. You add 27, 2 plus 7, 9. You add 36, 3 plus 6, you get add. So add this, add these digits, you are always going to get 9. Okay. After 90, what you will have? 99. Yes. You add 9 plus 9, You are getting 18, which is also a multiple of 9. So what you need to do, students, in this one, what is the divisibility rule for 9 then? That means you have to add the digits, whatever number is given to you, you have to add the digits, and you need to see if the addition that you are getting, if that is a multiple of 9, then we say the number would be divisible by 9. So let's take 1296. If I take this as an example and I add these digits, what do you get? 2 plus 1 is 3. 3 plus 9 is 12. 12 plus 6 is 18. So yes, this number will be divisible by 9 as well. Is that clear? So this is how we do these questions. If we don't have to divide and we just have to tell it just by having a look on the number. So these are some small tricks. These are some tests that we can do, and without the division we can say whatever the large number is, okay, that it is divisible by 9. Clear? Let us discuss the next divisibility rule, that is divisibility by 4. Okay. So in divisibility by 4, what you need to see, let's write, can you tell a number? Okay, if it is 2 digit, you can easily divide and get to know. The problem comes when the number of digits in the number is 3 or 4 or 5 and so on. So how do we check for those numbers whether it will be divisible by 4 or not? Okay, tell me about 212. If you divide it with 4, let's divide it. Okay, the number is 212. Dividing it with 4. 4 5s are 20. So this is what we are doing, the division actually, but without division we have to tell. So we are trying to figure out a short way of it. So 4 3s are 12. You see, exactly divisible. So 212, is there one another number? Suppose 1936 I take and I divide it with 4. Okay. So 4 4s are 16. You will be left with 3. Copy down this 3. 4 8s are 32. Then again you are left with 1 and you copy down 6. So 4 4s are 16. It is also exactly divisible. So what do you observe here? Just observe the last two digits, students. In the last two digits, the number formed by last two digits, here in this case it is 12, here in this case it is 36. And both of them are exactly divisible by 36. Let's try some more number for your trial. Suppose I have the number as 3516, okay, or I have the number as 9532. You see, this is 32. The last two digits are forming the number 32. Here the last two digits are forming the number 16. So 12, 36, 16, 32, they all are multiples of 4. So what you need to see is only one thing, like when you divide, you can check up with these as I have done for two numbers. You can also check for 3516 and 9532. But you will see that they are also leaving the remainder as 0. They are exactly divisible by 4. So what is the divisibility rule for 4? What you need to remember? You just have to focus on the last two digits. That's the ones and tens place. And if the number that is formed by these two digits, if the number that is formed by these two digits is divisible by 4, we say the complete number, let it be of it, let the number be of how many digits? It is going to be divisible by 4. So what is the divisibility rule of 4? The number formed by the last two digits, if it is a multiple of 4 or it is exactly divisible by 4, then we say the number which is given to us would be divisible by 4. So this is what the divisibility rule of 4. Now we will discuss the next one, that is divisibility by 8. Okay. So we'll discuss divisibility by 8. How do we do this? Yes. So I'll give you some numbers and we'll try to divide it with 8 and try to figure out as we did in the case of divisibility by 4. So let's take the numbers as 1000. Okay. If I take this number, I take this number, I take the number as 2005 and 12. Suppose these are some numbers that I have taken. Let's check if they are divisible by 8. Can you divide 1000 by 8? Let's try it out. So we have 8 ones are 8. You will be left with 2. Copy down 0. 8 twos are 16. You will be left with 4. Copy down 0. 8 fives are 40. Yes, exactly divisible. Okay. 2104. Let us try this one with 8. 8 twos are 16. Okay. How much are we left with then? 5. Copy down 0. 40. 8 6 are 48. So let's do it with 6. 48. See, we'll be left with 2, then copy down 4. 8 threes are 24. Okay, see here. Yes. So what we get, it is also exactly divisible by 8. Now see this one, this will also be divisible by 8 when you divide. What do you observe? Let's focus on the last 3 digits. So here we are discussing, when the number is 3 digit or less than 3 digit, you actually have to do it with the division. If the number is if the number has more than 3 digits, like 4 digits or more than it, then this is applicable. What is applicable? Just think about the last 3 digits, okay? Divisible by 8, divisible by 8, yes, 8 ones are 8 and 8 threes are 24. Then see 512, the last 3 digits I am talking of, the number formed by the last 3 digits, you have to focus on that and try dividing it with 8. If that is divisible by 8, we say any number would be divisible by 8 that has the last 3 digits. What? Okay, the last 3 digits and the last 3 digits are forming a number which is divisible by 8, then the complete number would be divisible by 8. What is the divisibility rule or the test for 8 or by 8? What we can say? The divisibility by 8, the divisibility rule by 8 says that take the 3 digits, okay, the last 3 digits of the number, and if the number formed by those 3 digits is divisible by 8, then we say that number is also divisible by 8. So this is what the divisibility rule of 8. Let us now discuss the divisibility rule of 11. Now, in the divisibility rule of 11, we have taken 3 numbers, 308, 1331 and 61,809. So these are the numbers divisible by 11. How do we check this? Just see. This is the number 308. So what do we do in every number like 308 is there? We position them and we position them from the right hand side. Like this would be the first position, second position and third position. Now what we have to do, from the right you keep positioning them 1 2 3 and 4. So you have to take the sum of digits with digits which are at odd places, like first position is odd, third position is an odd number, so 3 and 8 you will add them, added here, that is 11. Now sum of the digits at even places, that is 2 only and it is 0. So that will I have written. Okay, now we have to take the difference of these two. So 11 minus 0, you see it is 11. The next number will apply the same rule and we will see what comes up. 1331 is there. 1, 1, 3, 3, 1. So these are the 4 digits. First place, second place, third place and fourth place. So there are 2 even position, 2 and 4 and 2 odd, that is 1 and 3. So odd I will take 1 and 3 added here. Even is 3 and 1 again. So added that, the answer is 0. Let's try with the third one. This is first position, second position, third, fourth and fifth. So the odd position are 1, third and fifth. So at 1 I have 9. At 3 I have 8. At fifth position I have 6. Adding the digits which are at odd places, that is 23 after addition. And 1 and 0 that are at even places. So I have written 0 and 1. Added them, that is 1. Now you subtract them, the answer is a multiple of 11, that is 22. So all the numbers that you get, and you have to check if the number are of 3 digits and greater than 3 digits, then what you need to do is you have to position them first. Okay, start from the right hand side, position them as 1 2 3 and 4 like this, whatever the digits you have. Then you take up the digits which are placed at odd places and take up the digits which are at even places. Do the sum of those and subtract that. That means we have to find out the difference of both of the sums. So when you find the difference, either it would be 11 or it will be 0, or it will be a multiple of 22. If these kind of answers we are getting a multiple of 11 itself or 0, then we say the number is divisible by 11, otherwise the number is not divisible by 11. So basically we don't have to exactly divide, like 61,809, that is a big number, large number, but we haven't divided it with 11. So such small tricks help us for faster calculation. So these are some divisibility rule, very simple, that we have discussed. So these are all the divisibility rule we have discussed from 2, then we discussed for 3, 4, 5, 6, then we have discussed for 8, we have discussed it for 9, we have discussed it for 10, we have discussed it for 11 as well. So this is all the part that I wanted to discuss at conceptual. Let us practice one or two questions now. So let us practice these two, and here we have to check the divisibility by 11. In the first 5, 4, 4, 5, let's position them 1, 2, 3 and 4. Okay, digits at odd places. So I'll take the sum, okay, sum of digits at odd places. There are two odd places, if you see, that is 1 and 3. So 5 plus 4 is 9. Then next is sum of digits at even places. What do you get? Just see, 2 and 4. These are the two even position. So 5 and 4 only we are going to add. That also gives us 9. If I subtract these two, the difference is, you see, what is the difference that we are getting? It is 0. So yes, the number is divisible by 11. Okay. Now we will discuss this number. It's a large number. Let's do the second part. Okay, so the number is 70169308. 70169308, these are the digits. Let's position them. So to position them, this is first position, second position, third, fourth, fifth, sixth, 7 and 8. There are 8 places. Out of them, 4 are even, 4 are odd. So if I take sum of digits, okay, at odd places first. At odd places, I see I have 8, okay, then at third position it is 3, then fifth position it is 6, seventh position it is 0. Add them. 8 plus 3 is 11, 11 plus 6 is 17. Do you see? Okay, 8, you add 3 to it, it is 11, 11, you add 6, that is 17. Now you take sum of digits at even places. Even places, at second position we have 0, at fourth position we have 9, then at sixth place we have 1, and eighth place we have 7. So 9 plus 1 is 10, plus 7 is 17. So can you subtract them? 17 minus 17 is 0. So this number is divisible by 11. So this is how we check the divisibility by 11.